In this video, I'm going to be showing you the process of assembling this little LED flasher board using this manual solder paste dispenser, this vacuum pickup tool made from a reversed aquarium pump, and a Bic pen, and a part sheet. The first thing to do is to paste up the board, and we're going to do that right now. The idea is to place a little dollop of solder paste on each of the pads. I'm going to go from right to left so that I don't mess up the little dollops that I've made previously. Because I'm left-handed. That looks pretty good. I'm going to cover this back up. And now it'll be time to actually place the components. Now I have on this part sheet, since there are enough parts for 9 copies of a board like this, what I've done is I've gone through here with a craft knife and I've made slices in the tapes here, right here, for the right twomost ones, for the ones that I need 2 components of, and I've made slices through just the last bit of tape so that for the components that I only have 1 of, and that way when I peel off the tape I don't have to worry about the flap of tape flipping back over on me. So I'm going to be placing these components using this vacuum pickup tool, and I also have the interactive bill of materials up here on a little Raspberry Pi screen so that I can check them off as I go along. And I might normally have this up on a laptop, but since this is a nice small screen, I figure I could get in the shot, so we're going to do that. So I'm going to turn the vacuum pickup tool on. And I tend to like to have parts rotated this way. And my first component is this 0805 capacitor. And I also like to orient the board so that the components are horizontal when I place them. And so I'm going to peel off the tape. I'm using this green needle for the 0805s and the SOT 23s. Now it turns out that you don't actually have to break the vacuum for the components to separate from the vacuum pickup tool, which is really nice. The tackiness of the solder paste will do that for you. So now I'm going to switch the needle to the purple one for my 0603 components, and most of those are oriented horizontally, so I'm going to flip the board back around this way. So I'm going to check off this box here for the two capacitors I just placed, and you can see that the interactive bill of materials actually marks those parts, or highlights those parts as already been placed. So the next two components I'm placing are these two capacitors. Those off. Next ones are these resistors. Next two are these two resistors. Next we got this one resistor. And the last 0603 component is this resistor here. Check off that last one, and this one is that one right up there. Now we're on to the 0805s. We have an LED and the two SOT23s. So go back to the green needle. And now we're on to the SOT 23.5. I'm going to rotate the board this way for that one. And finally the SOT 23.3. And that's all the components on the board. So you'll notice the alignment's not perfect on these, but it doesn't have to be, because when it goes in the reflow oven, the surface tension of the solder will actually snap the parts into place and align them with the pads. So that's the next thing, is to reflow the boards. This is my home reflow oven setup. It's basically a Hamlin Beach toaster oven. It's a convection toaster oven. Just an ordinary run-of-the-mill toaster oven, unmodified, except that I've covered the inside of the oven glass with this Reflecti-Gold high-temperature heat-reflecting tape to try to keep some of the heat inside. I did that when I started reflowing, or trying to reflow lead-free boards. And the nice thing about this particular toaster oven is that the lid opens this way, or the door opens up like this, and you can see I've added a stainless steel temperature probe like you would use for a barbecue or a smoker, and I've got just a kitchen timer here. And so this is a completely open loop setup. I don't have a reflow temperature controller, and I just have calibrated a couple of points on the dial, just below, slightly below 250 gives me a temperature of about 150 Celsius, and that is sufficient for the preheat phase. And then just over 400 gives me a temperature that's good for the reflow phase for lead tin solder. For the lead-free solder, I basically just crank it all the way up, and the temperature maxes out at about 235, sometimes 240, and that does pretty well for my lead-free reflows. So we're just going to turn the oven on and wait for it to preheat. When the temperature gets to about 150 C, I'm going to put the board in the oven, and when the temperature returns to 150 C, I'm going to start the timer for the preheat phase, which is about 1 minute and 30 seconds. And then when that ends, we'll crank the temperature up to max. And when the alarm goes off on the thermometer, which is set for 220, which is the roughly the reflow temperature of the SAC 305 solder paste that I'm using, then we'll start the second timer, which is for 1 minute for the reflow phase. And it's generally a good idea not to let the board flip over when you open the oven out and pull the tray out. At least not before the solder melts or hardens, solidifies. Well, it looks like it may have done okay. Generally like to wait till the temperature gets down to about 50 or so before I move it, but let's see if we can adjust this and get a good look at it. It looks like it did pretty well. Reasonably happy with that. The components look reasonably aligned, and there is no tombstoning. Well, the next step is to solder the through-hole component, which is the USB Type A connector. Okay, now it's time to do the through-hole soldering, which is just this USB Type A connector. And the first order of business is to put the USB A connector through the holes and through the little board locks, and make sure it's flat-ish. I'm going to put it upside down, like so. And now we're just going to use soldering iron. I have an 800-degree tip, which is recommended for the lead-free solder, which reflows at a higher temperature than leaded solder. And we're just going to heat the pin and the ring, the pad, and let some solder flow in there. This is SAC 305 lead-free wire solder. And now we're going to solder the board locks. Clean off the soldering iron tip. And that should be that. I usually like to clean off any of the flux residue. It's left behind with a little isopropanol. And there we have it, an assembled board. Now all that's left to do is to test it out. Now for the moment of truth. We'll see if it actually works. We have blinking. It works! Hooray! Thanks for watching.